Thank you, Terry. Whoop. Okay. So yeah, next up we have Aaron Lowry, who was one of the first cohort at ETC Labs, working on Ethernode, which no doubt he's going to tell us a little about here.
A little bit. Try to keep a lot of the focus, thanks Bob, more on some basic educational principles related to network infrastructure, and maybe get a little bit of a bigger picture view of some of the challenges that are faced in our attempt to develop functional DApp ecosystems and attract users in ways that provide meaningful and lasting value to them. So I think there's a general consensus around the fact that we're looking for these viable distributed applications to provide some fundamental value to these blockchains in general, specifically ones running an EVM. And so it's really important, if you're looking to try to begin engineering an application that can provide value to an end user, that you understand the network constraints that we're dealing with and engineer appropriately. So I'd like to start by taking a quick look at these network depictions and go over some of the contrasting elements of them. And the public network architectures that are depicted here show the internet on the left and an Ethereum virtual-based machine environment on the right. And you can see there's sort of a scale for decentralization there. And these are terms that we utilize pretty freely, things like decentralized permission versus permissionless. But it's not always clear exactly how we're defining these things. So the internet is sort of a centralized yet decentralized network. It involves a lot of hard infrastructure that we take for granted frequently, especially in countries like the United States, Western Europe, and places that invested heavily in them. It involves a few significant players at the top rungs, and it's very has a very distinct hierarchy of permissioned services. So to give you a little bit of an example, and we're all pretty familiar with this, if you work from the user out, you are accessing this public internet through a permissioned device where you have a MAC address that's attached to a modem, whether it's a cable modem in your home or it could be a mobile modem in your phone. Regardless, you're using a specific hardware address, and it has to be permissioned by your internet service provider. Now, your internet service provider most likely is just local or maybe even regional, but they're also permissioned to connect you and your data to the rest of the existing infrastructure. And this contains for a lot of this stuff is kind of elementary, so many of you probably are familiar with it, but maybe some people who are watching won't be. This is then run through a series of, you have DNS servers to resolve names. You have data centers to distribute and store most of this data because it's economically inviable for us all to be pulling data peer-to-peer all the time. And there are numerous points within this network that have different vulnerabilities. And a lot of these vulnerabilities are addressed in a distributed network scenario. You have, instead of a hierarchical kind of construction, you have basically an equal peer network, and that is truly permissionless to join if you run a client and it meets the qualifications to join the network. It doesn't care who you are operating it. And so these are very very fundamental properties to these networks that provide a lot of value to them. Now, the challenge that we have here is that the blockchain networks that we're hopefully participating in if you run a node, or at least accessing through someone else's node, you're still dealing with this entire hardware infrastructure of the current internet. And it's kind of depicted here with some of my limited design skills. But you can see pretty clearly, if you're the user and these are your devices that you're connecting, like this is pretty much how it goes. You go through your router and your modem, and that's connected and permissioned by your ISP, and then that spreads out to some routers and switches, and like these are all points of hard infrastructure. They're privately owned in most cases, and you're paying a service fee just to access them. There's also some of these other points where I mentioned of potential failure, or at least vulnerabilities through DNS servers, data servers, and this is all really interconnected through a relatively limited but fairly robust network of fiber optics, most in general. Now, when you run a blockchain node, you participate in one of those decentralized, distributed types of networks that we described before, and this image tries to depict a little bit of how these look. Now, we use our Nkeep logo here to represent a node. This is a piece of node hardware that we've developed specifically to make it easy for individuals and enterprises to host blockchain nodes in a local environment. But you'll notice even in this, this infrastructure here, you have the node is still behind your modem. You can't connect to the rest of the network without that key piece of hardware and the permissions that are involved with it. But once you do, you can see here it starts to develop the properties of a distributed network, but it's still all running on top of that other existing infrastructure. And these are this is a scenario that's often not really well addressed when we're trying to imagine or engineer distributed application systems, because the vulnerabilities to the core underlying network are extended to the blockchain networks that we're operating on top of them. So in an example like this, and I think I wanted to point this out as well because you don't hear a lot about it, but these EVM networks are all one network, even though they have separate blockchains and different data ledgers running on these nodes. These all actually talk to each other all the time. So here, you'll have an Ethereum node and an ETC node and a Kadi node or a Morden node, and the actual data ledgers that they contain are different, but they all have an eNode address, and they're capable of communicating one with another, make handshakes all the time. And this is an important point because, let me touch on this too. So this is a brief interjection about Ethernode here and our Nkeep hardware. It's actually designed to replace a router in this infrastructure setting. A node is your blockchain gateway, but it's still a gateway that's behind your modem, your internet gateway. But there's a pretty decent argument to be made for running a node and a number of features of blockchain specifically that you can't access or utilize if you don't. One of the key things is having an actual network identity. This is depicted as an eNode address, and it gives you actual peer status within the network and an address that you can send and receive transactions from, enabling P2P interactions and utilizing different protocols like, for instance, Whisper, which is in the Ethereum client, for transmitting secure encrypted data across the network without necessarily involving network fees because you're not hashing into the blocks. you're also reducing your dependencies. The underlying value proposition of a public blockchain is trust minimization. You really are trying to eliminate the number of parties that you have to rely on for valid access to your data or handling of your data. And if you're relying on, say a centralized infrastructure solution like Infura, you're reintroducing a lot of that, those vulnerabilities that you portend to be trying to eliminate in the first place. So it's really critical when it comes to just blockchain interaction. And it gives you the ability when you have a copy of a ledger living locally on a piece of hardware to query it very quickly, very securely, and with a lot of flexibility. So these are really critical elements to or justifications for running a blockchain node and participating in a blockchain network. So a lot of what we do is combining or recombining different technologies. And events like this are a good example of kind of how this occurs. Like Zane was talking earlier about the service runner. These are the kind of technologies that we've been integrating into the operating system that we developed to run on the in-keep hardware, and is kind of the fundamental basis of ENOS, which is our Linux-based blockchain operating system. So one of the things that we've done here, and you'll notice on this slide I've shown, we use what we call the NAPI, and we've developed all the software in fairly modular components, and many of them utilize technologies that are developed by people here, and some other technologies that are very commonplace and some quite old. But the NAPI is something you can use standalone or with the other features in the software, but it's based on OpenRPC spec JSON RPC and allows you to interact with the nodes that you've hosted locally in a lot of standardized but dynamic ways. In the NOS interface, you can click a button, host a variety of different nodes, and then also run applications that have the ability to interact with one or multiple nodes at once. Also using things like a local wallet so you can sign transactions and really begin to automate a lot of these things in ways where everything happens, all the processes happen locally. You're not reliant on any third parties for any of the interactions you perform. It's especially valuable for people who are doing development or in many applications like this, for say like an enterprise solution where maybe you want to run a private permission chain on one side where you're accumulating large amounts of data that would be uneconomical to process on a main chain, and then with the ability to write data to a main public chain as well, where it can be trustlessly verified by third parties. One of the things that led us into blockchain a number of years ago, because we come from a background of IoT systems and system deployment, and so we were attracted originally to Ethereum Classic because at the time it was positioned as a blockchain for IoT support, IoT data transmission, and that hasn't yet materialized, but we're constantly working, recombining different technologies to help enable that, and do so in a way that's as decentralized as possible while still operating within sort of the underlying fundamental constraints of an internet-based system. So this is a sort of a brief but descriptive depiction of how we're currently sending IoT data across public networks, but in a manner that's economically viable. So we use the Whisper SSH client running on like a light firmware on an edge device where we can take and parse in data from a variety of sensors and then hash that and send it off via a bytecode across the network where we can subscribe to the topics that it broadcasts with a base node, and then we take that data and decrypt it and parse it into a database there. And from that point, we're able to utilize it in kind of whatever manner is applicable based on the use case. And these are the kind of transactions that you really are only going to be able to perform if you're running some type of a client where you're part of the network. If you're trying to do any of these kind of processes without running a node or some sort of a light client, then it's pretty much unachievable. That you might as well just stick with a standard kind of IoT system. But all of these things, again, are constantly kind of in development. I think the Fly client work that Zach was talking about earlier could be hugely impactful on especially the edge side of these kind of equations. And so we're just working to constantly integrate a lot of these tools. The platform of ENOS allows us to do that pretty readily and take tools from, say, an IDE to a wallet to basic applications like that, and just integrate them right there in the operating system where they run locally, and you can interact with them in a secure and local manner. So feel free to hit us up anytime. We are happy to hear about projects people are working on, ways that you want to utilize these kinds of networks, because a lot of times the value proposition for them is still kind of undefined. We're still based around this idea of trust minimization as the fundamental purpose of utilizing blockchain in the first place, especially in a public and decentralized manner. But we face a number of challenges, specifically in the fact that it's still based on the current network infrastructure of the internet. One note on that front, we also, in the InKeep hardware that we build, it's all mesh network enabled. So this has very sort of geographically limited implications currently, but it is the kind of technology that can enable a freedom from that base of the current internet that we're currently operating on, and open up a whole new realm of actual decentralization and distributed network potential. So thank you.
The Encrypted is a hardware node, no?
Yes, sir.
That someone can have at home or the office. What client does it use, and does it ship already synced? So you just have to get the last few blocks, or does it ship empty and you have to synchronize?
We ship the hardware unsynced. That's an extension of our desire to kind of promote trust minimization. I guess it's kind of a little bit of a toss-up there. If you pre-sync it and then let it catch up, you're still going to, once you reach the end of the chain, you're going to be able to validate the whole thing. But we support currently Geth and multi-Geth in the client, and formerly Mantis as well. But you have options in there. As you go to spin up a node, you can select which chain you want to run a node on. Multi-Geth is very good for this because it's supporting all these different EVM platforms. But yeah, you have options whether you open RPC ports or not, configure which type of sync you want to perform, archive to a light sync, to try to just give the user some flexibility and all that as well. And also it supports the POA click network. So you can, you could host a Kodi node, or you can create your own POA chain with a click of a button there as well.
So I just have a follow-on question for that. So you were using Mantis until it wasn't supported for Atlantis. So what was your experience there with Mantis?
We think Mantis is an excellent client. It's beautifully written. It's extremely efficient. It has a smaller footprint. The challenge that we ran into with specifically for the Inkeep is support for ARM architecture. So the Inkeep is an ARM-based processor, and currently, obviously Mantis hasn't upgraded to support Atlantis, but even previous to that, it was just running on x86. So that was sort of a challenge right there, but it's a very well-written client. It's a good piece of software. Very good.
That's actually, ARM Linux is how my Ethereum adventure actually started, was porting CPP Ethereum to ARM Linux. Mm-hmm. And yeah, I know the challenge.
Yeah, and it is, and we're not Scala devs, so we're kind of limited on our ability to kind of compensate. Yes, sir.
In your opinion, what do you find one of the biggest hindrance or challenges to implementing this distributed network? Like getting these nodes out on a large scale?
In a practical sense, a lot of it is a value proposition for the customer. And I think that there's a better argument right now for a value proposition for things like enterprise deployment. Although I'd love to see users everywhere running a node, syncing a hardware node in their home and all that, and we developed hardware to help facilitate that. Without good, useful applications that run on top of it, it's really only appealing to developers or maybe people who want to pull real-time data from chains for trading purposes or some other things like that. But user adoption really is about developing applications that are value sustainable for the customer and the end user, and those are still to be developed, I would say, in many cases. I think on the enterprise side of things, there's a very good value proposition for private permission chains that are used to aggregate data produced, whether it's in, say, manufacturing or supply chain environments or something like that, where you can accumulate it in an environment where you get the benefits of blockchain, which are mostly in these applications used for compliance and audit, those kind of usages, but also have that in an environment like we've tried to facilitate with NOS, where you can have your own private chain running here and all your datas go in there because there's a lot of it, and you could never economically put that on a main chain. But in an environment like this, you can actually take your data that you're producing from your private chain and snapshot it or incrementally publish it to a main chain for trustless verification.
Like on the other side of that, like how attractive would it be to Ethereum Classic developers to have access to a larger node system? Would that?
I'm not sure how to quantify the attractiveness, but I think there's a benefit for everyone involved in the technology if widespread distributed node ownership and usage grows, it adds robust nature to the network. It reduces latency times, and in many cases, and a healthy distributed network is one that has lots of participants. And if you're not running a node, you're not participating. So it's of benefit to all of us. Tangible benefits for users, it really depends on use case.
Earlier you spoke on the centralized permission levels within internet connectivity.
Yes.
With recent concerns such as net neutrality in the States, are there any plans to circumvent issues at higher tiers, such as replacing servers, for example?
So I think the answer to that lies within technologies like mesh networking protocols. Short of that kind of actually distributed network where the users are all peers and you don't have sort of the hierarchical structure where at different points it could be cut off or limited or restricted, then that would be an ideal environment from a networking standpoint. Practically transitioning from what we have today to something like that there's a lot of entities that would be highly disinterested in that occurring, and so there's some challenges there, and just the practical aspects of transition are substantial. We'll still work for it, but yeah, it's challenging.
Question. So what efforts, if any, are being made with regards to framing this kind of in the public good? Schools, libraries, universities are running this infrastructure, not so much for, quote unquote, the proprietary usage of a particular blockchain, but to create redundancy with regards to mesh networks, a secondary layer, et cetera, a whole other layer of utility that could be run. And there just also happens to be this, the blockchain functionality built in there. So, Samsung's done this with their phone, for example. What, if any, efforts are being made with regards to establishing these partnerships with hardware manufacturers so that this is an additional option or module that could simply be included with the purchase of this commodity hardware?
I don't know if I can speak to that in like a comprehensive large scale, because I don't know exactly what advance or intent some people or organizations have, or what kind of actionable measures they're taking on those things. But I think probably realistically the most impactful ones involve things like low Earth orbit satellite from an actual network and even mesh network propagation kind of scenario. On a institutional level, like you're saying, I think there's a lot of value, especially in larger distributed, private systems, for viable and efficient backup and redundancy, and it's something that we have a geotelematics company. I've done this for a number of years, and it just runs an SQL database, and it accumulates tremendous amounts of data. And in order to provide the kind of safeguards for that data and for our customers and all that, we have to run multiple redundant backups that are distributed around geographically and things like that. And you're able to achieve a lot of those inherently by running like a private blockchain network. The nodes that you run on it, they're just naturally going to be distributed backup and redundant systems. So I think that's one of the greatest benefits to that kind of network architecture from a private or institutional or enterprise kind of standpoint, for sure.
Thank you.
Thank you. Gracias.
Thank you.